All right, so Unit 5E, we're talking about correlation and causality. So a lot of what statistics is trying to do is show that one thing causes another thing to happen. And that's where correlation comes in, is they're looking for what's called a correlation between two things going on. So what a correlation means is it exists when there's two variables, and one variable increases, the other variable also increases. Or as one variable increases, the other variable decreases. So you start to look for these correlations, like smoking and lung cancer. The more people smoke, the higher the risk of lung cancer. And this is going to come up a lot in this unit, this idea that smoking causes lung cancer, and how it came about. But there's a correlation between the amount that a person smokes and the chances that they're going to get lung cancer. It doesn't mean that just because you smoke once, or even just because you smoke for a lot of years, you are going to get cancer. It just means that there's a correlation between one and the other. So a few others, and some of these, sometimes it's really obvious, like this one, the correlation between the variable height and weight for people. Taller people tend to weigh more than shorter people. Well, taller people are taller. There is more of the person to begin with. So whether they have extra weight on them or not, they already are starting out heavier. So that seems like kind of an obvious correlation. The correlation between the demand for apples and price of apples. As demand goes down for apples, the price increases. Okay, or I guess the other way around. The demand decreases as prices go up. So as apples get more expensive, less people want to buy them. So that's another type of correlation. One goes up, the other one goes down. There's also a correlation between practice time and skill. This says among piano players, but I would argue that this is among anything. Okay, I don't care if it's the piano, I don't care if it's basketball or track or math or anything else. But as practice time goes up, the skill usually goes up. All right, so where we start to use this is just a table of, this only goes up through 2016, but these are like the 15 movies that spent the most money. And the question is there a correlation between how much money they spend making a movie and how much money the movie actually makes? And so what you see here on the left is the amount of money that a company spent making a movie, and on the right is how much money they made from it. And a lot of times in a table, it's hard to see. You see Pirates of the Caribbean with a high production cost, and they made a lot of money. But then you see Star Wars with a lower production cost, make a lot more money. And so the numbers kind of bounce around a lot. You look at Lone Ranger, a really high production cost and significantly lower than some of these other amounts of money made. Okay. So it's really hard to see the data in a table. So we usually will use a scatter plot when we're starting to look for this correlation. And the way a scatter plot works is each dot on the scatter plot represents one of these pieces of data. So like Avatar right here spent 237 million and they made 761 million. So across the bottom, you're going to have one of those. The cost of production goes across, and going up and down is how much money they made. So Avatar is right up here. So it spent about $237 million and it made 761. And you do that for each piece of data. And then what you're starting to look for is as these dots go to the right, we look for them to also go up. Okay, that would be one type of correlation. Or as the dots go to the right, you expect them to start out high and to go down. Now, these dots are kind of all over the place. You have a lot of them just kind of grouped right here. And then you've got some major outliers. Pirates spent a lot of money, didn't make a lot of money. Avatar didn't spend a lot, made a whole bunch of money. Star Wars was right in the middle. And then there's all of these that are just kind of floating around in the middle. And what we're looking for is a line, or at least the tendency for there to exist a line. And they're not always going to be in a perfect line, but we're looking for kind of a trend. Okay, so here's two examples. On the left, it's showing the diamond weight across the bottom and the price of the diamond going up. And as you would expect, as the weight goes up, as the diamond gets bigger, the price is going to go up. And if you look at the graph, you notice that there's kind of a trend of that happening. As I go to the right, I go up. So this is what's called a positive correlation. And what that means is as one increases, so does the other. The one on the left goes the other way around. It's comparing life expectancy and infant mortality. So as infant mortality goes down, life expectancy looks like it's going up. You see this downward trend. And there are some outliers. Kenya and Russia don't fit right close to the line. They lie out a little bit. And that's where, so this one in general is called a negative correlation because it's going down. As one goes up, the other one goes down. We also consider the strength of the correlation. The closer these are to a straight line, the stronger that correlation is. Okay. If you have a bunch of dots out here, then that's a weaker correlation. They still tend to go up, but they're not grouped together as closely. They're not as close to the actual line. So this one on the left has a pretty good correlation. This one on the right has a really strong correlation, other than you always may have a couple of outliers. No correlation exists in like this example. They don't really follow a trend. It looks like there might be here in the middle, but I would say that there's really no correlation here to the amount of money that's spent and the amount of money that the movie makes. Okay, at least not a direct one. So here's a few examples. Here's the inflation rate and unemployment. For a long time, they used to say that there was a correlation for the unemployment rate and inflation. And if you take this data and put it in a scatter plot, what you're looking for is either a line going up to the right or a line going down to the right. And what you end up with is kind of a straight line across. You don't really see that increase or decrease moving in a pattern. So this right here looks like there is no correlation between the two, between the unemployment rate and inflation rate. Okay. This one, example of accuracy of weather forecasts. So on the left, we have the same day forecast. On the right, we have a 3-day forecast. And if you look at what at the bottom is the forecasted temperature, on the side, on the y-axis is the actual temperature. And if you look at this trend, you kind of see that it looks like there's a positive correlation. As they predict the weather is going to go up, the weather goes up. And then over here on the 3-day forecast, it's the same thing. You still see this correlation, but look at how much tighter the numbers are grouped on the left than on the right. On the right, you've got some outliers that are a little bit further away. On the left, they're a lot closer together, which makes sense because 3 days away, they're not going to be able to predict the weather as well as they're going to on the same day. On the same day, most of us can predict what's going to happen to an extent. 3 days out, it's not as accurate. So there's still a correlation. It's just not as strong as it is on a same day forecast. So one thing to consider is just because it looks like there's correlation, you've got to keep in mind what is causing that correlation, okay? And there's really 3 explanations. One of them is it's just a coincidence. One of them is it just happens to happen that way. Another one is that both of those variables are being influenced by something else. In other words, they're not influencing each other, but there's some other variable that is causing them to both do what they're doing. And number 3 is one of those variables may actually be causing the other, okay? That correlation may not just be a correlation, but one may be causing the other one to happen. So example 3 says to consider the correlation between infant and the mortality rate, which takes us back to right here. So what this looks like is as your life expectancy goes up, babies are less likely to die. Or as babies are less likely to die, your life expectancy goes up. So you're looking at which type of correlation is that? Is this one, is babies surviving leading to longer life expectancy, or the other way around? Is this just a coincidence, or is there something else causing both of these to happen? And that's what I would argue. I would argue that one isn't causing the other, but in general, if you have a low infant mortality rate, that means that you probably have a pretty good healthcare system, which means that people are probably going to live longer. So I feel like that there is a correlation, but one doesn't cause the other. They are both being affected by the quality of healthcare in that country. Okay. And then our other example, I like this one. So the stock market tends to rise for the rest of the year when a team from the old pre-1970 NFL wins the Super Bowl. So you have a lot of old NFL teams from before 1970, and then you have new NFL teams. And there is this correlation that when one of the older teams wins the Super Bowl, the stock market rises for the rest of the year. In fact, it's like an 80% correlation. 80% of the time that the old team wins, the stock market goes up. So should you say that one causes the other? And I think this one's an obvious, absolutely not. There is no connection where a winning team in football affects the entire stock market in a country. This is one that we would absolutely call a coincidence. Okay. One is not causing the other. There's not an outside factor influencing them both. It just happens to work out that way 80% of the time. I don't think that's a good enough reason to base your investments on who wins the Super Bowl. That would be a pretty brave choice there, but hey, that's up to you. Okay, establishing causality. Now, I've got a case study down here. I'm going to have you pause and read in just a minute. But once you recognize a correlation, you've got to make that decision or you've got to go through the process of finding out, okay, there is a correlation. Is one of these causing the other, or is it one of these other factors? Is it a coincidence? Is something else making both of these happen? Maybe with lung cancer and smoking, is there a gene that causes people to be more likely to smoke and more likely to develop lung cancer? You have to go through steps to establish, yes, this actually causes B to happen. So if you suspect a causation in this correlation, the 6 steps that they go through, first, you're looking at situations where the effect is correlated with the suspected cause, even while other factors vary. So in other words, with the smoking, you're looking at men and women, all different ages, all different countries. You're not just looking at smokers. You're looking at lots of other factors that vary. Does lung cancer go up in men and women, all different ages, in all different countries when that person is smoking? Now, among those groups that differ, only in the presence or absence of the suspected cause, check that the effect is similarly present or absent. So in other words, looking at lung cancer in men who smoke compared to lung cancer in men who don't, is that the same relationship? Do you see the same tendencies that you see for women who do and do not smoke, and people from China who do and do not smoke, or people from Africa who do and do not smoke? You're looking at both factors for each group, Okay. Then you're looking for evidence that larger amounts of this cause produces larger amount of the effect. So people who smoke a lot more, do you see more cases of lung cancer as opposed to people who smoke a little bit and finding lower amounts of lung cancer? Number 4, if the effect might be produced by other causes, make sure that the effect still remains after those causes. So when they did this with lung cancer, they started looking at the other things that cause lung cancer. And once they eliminated things like radon and these other cases where people were exposed to other harmful substances, all that was left was smoking. So they eliminated all the other possibilities that could have been affecting it. If possible, test the suspected cause. And again, with smoking, they did this. They experimented on animals that didn't have any of these other factors. They just had animals smoke and saw that more of the animals, the more they smoked, the more likely they were getting lung cancer. And then number 6, try to determine the physical mechanism. And again, with lung cancer, they did this. They broke it down to a cellular level and were able to show clear down at your basic cells what some of the chemicals in cigarettes and nicotine do and how it affects your cells to lead to causing lung cancer. Okay. You have to go through those 6 steps. You have to be able, you can't just say one causes the other because it looks like it happens. You have to go through the steps to actually show that that is a true causality. Now, if you'll pause the video real quick, I want you to read through this case study. I don't want to read another long list to you. So pause the video. I just want you to take a few minutes, read through that case study, and we'll move on. Okay, so even with cell phones, it looked like there is a causality, but they can't just jump up and say, oh, yep, one causes the other. They went through a long process of trying to show and eliminate other factors to show that that actually is something that it's affecting. And what they found was it wasn't just cell phones, it was any distraction in general, which cell phones tend to be, along with small humans in your backseat. Okay, so homework 5E. You can work on that at home. We will work on that in class and answer questions when you get here.